So I have received a box of goodies, and I thought I would open this up and maybe talk through what I have here. Packaging, this is different than I've typically gotten from JLC PCB. This is not the same type of box, and I'm not sure why there's a difference here. But I don't have the normal blue boxes I'm used to. So they switched that up, and maybe it's because I have some surface mount work that was actually done. And maybe that goes through something different on their end. But this is my stack of goodies. So let's see. Maybe I'll just start with the bigger ones here. Set these little guys off to the side and come back to those. And if I look at this, this is my upper and lower PCB for the 386DX that I'm working on. And I think I'm kind of curious just to see how well these are going to sit on the chassis. So I might just get this opened up here. And pull one of these out. And then I think I'll pull out one of the bottoms. Okay, and then the idea with these is that they would sit in this chassis that I have that looks like this. And this is a large chassis here. So this is an ATX form factor, but an extended ATX. So it's just a large ATX form factor. And then off to the left, this will screw on so that all my add-in cards will sit here. And hopefully, if I didn't mess things up too badly here, this should sit on these standoffs. And I have more standoffs, so I had to order more standoffs. And if you can see anywhere there's a circle, I need to add a standoff yet. And where there's X's in the normal pattern, I'm not going to use those. And so this is going to sit in here somewhere like this. And it looks like it's fairly close to lining up on all of these mounting points. So I'll just have to double check and make sure that that all looks okay. And there's some missing ones here, so I'll get those all put in. And then the same thing up here. Those hopefully will line up and sit on that. And hopefully between the measurements I did and this chassis and the actual PCB manufacturing, this will all come together and fit on here. It looks, at just first glance, it looks like it's pretty close. So that'll be what my full board is going to look like. And so there's a lot there. Maybe even slide this up a little bit more on the camera. So I think that is fitting in the camera frame there. But that's what I'm looking at there. Now, if another part of this that was something I had to make sure I got right on the physical is just the connector between the upper and the lower. So I have a pair of connectors. I'm using these connectors here. And so when those are fully inserted, I have a set here that's fully connected together. Hopefully, the goal is that this will connect up on here. And it looks like that is fitting just right. So maybe I got pretty lucky there. I did probably measure 4 times as I got into this, but sometimes the exact edge of the PCB isn't always what I expect when I get them. Okay, so that's going to sit on there, something pretty close to that. And that those are seated. So I think, and this just doesn't have a mount underneath it, a standoff, so it's sinking down. But if I hold that up, that's what I'm looking at. And then to add to that, I have these. And this is another question: is this the right? Did I get the right setup for these? These are PCIe connectors, and that looks like that's going in just fine, which is good. So I had taken an existing footprint I found and modified it slightly, but these look like they're going to fit on there just fine. So I'll have 4 of these, and that's what I'm going to use to connect up any of my debug cards, whether it's going to my Agilent devices or to my PC through an Arduino or other type of debugger. Okay, so that's looking good. And then on top of that, I'll have my ISA slot. So I have a standard ISA slot connection here. And I'm not going to push that all the way in. But then for some of these, I wanted the extension. I didn't want to do another full ISA slot. That didn't quite fit. So I am going to use an extension that looks like that. And really all I'm doing is I'm just taking one of these standard ISA slots and cutting it. And the reason I'm doing that is these are really inexpensive. I'm trying to remember, what were they, 29 cents or whatever they are each. And so to take one of those and just cut it in half is cheaper and more available to find parts than just this piece here. And someone did ask if I've considered other, like VISA local bus or something like that. And I was hoping to do VISA local bus or ESA, but I can't find the parts to do that. So that's not an option. So this is what I have so far. The bottom is pretty basic. Really, I have a bunch of open space that I can do something with later. Maybe I will put an IDE controller right in this space so that I can just directly connect rather than having an add-in card. But that'll come later. Otherwise, these are just my ISA slots, I'll call it a proprietary extension I'm adding to get to a 32-bit type of a slot. And then my little debug ports and my connectivity to the upper board. And it might be that I revise the upper board but leave the lower one. Plus manufacturing, it seems like it's easier size-wise to have these 2 smaller boards and connect this together. Challenge might be what speed I can get out of the system. This is a large board, and then I'm going through these connectors. So we'll see what kind of challenges I have with that. But I'm going to put these back for now. And I'm going to pull these off. So, looking at this board here, nothing too exciting beyond what I've shown. I've got some power connectors around the board. That's really not a big deal. I did keep this a 2-layer board. So I should be able to cut traces if I need to and run bodge wires pretty easily for anything that I didn't quite get right. And then for the upper board, same thing. And as I look at this, I'll pick up where I left off on the previous board. So I'll get the processor back in, all my latches and transceivers, my single flash, and then a small PSOC that I'm using to basically shadow that, to get that shadowed into RAM on initialization of the system. I've got my RAM sitting down here, and I want to get all of that back in like it was in my other system with, no bodge wires, which my other system does have. And actually, I could grab that here real quick. And this is a bit messy, so I'm going to just pull this off of here. But here's my previous system. I've got the debug card over here. That this was the STM32 based card, which I probably won't be using at this point on the new system here. But then I have this little clock card off to the side. I had gone to this single ROM setup, so all of this wiring this wiring, all of that's just in the board now. And if I do flip this over, just to kind of give you an idea, you know, there's quite a bit of bodge wire work that you can see right over here. So as I was building this out and deciding which signals were going to which PSOCs, I was doing some tweaking, and you'll see that I have maybe some cuts. I have some markings just to kind of remind me what's where, and a whole lot of bodge wires. So all of those changes should be incorporated into this new set that I have below. So I'm going to get this mess out of the way. But that should give me this clean board up to that point. So then I have a lot of work to do yet that hasn't been vetted yet, and I'll start working through that. But the next thing I need to get done is to get this VIA working. And once I get that working, then I can see if I can get SPI working. And if I make it that far, that would be great, because then I can do basically a terminal type of application or communication to my PC if I want to do that, which I do. So I'll get that going. I'll get a little debug. I have a nano sitting here that will actually do that type of communication to my PC. And then I can start working on all the other things that I don't have done yet. So math coprocessor, keyboard, mouse would probably be two of the big things that come to mind. And then, of course, trying to get an actual card, like a video card working here, that would plug in to one of these just 16-bit ISA slots that I have already. So that's these. I'm going to set those off to the side for now and get this big thing out of the way. And then let's see, I've got a few other packages to run through here. One of the things on that board for the 386 on the lower board, again, were these little debug slots. But what I'm hoping to do then is to use one or more of these adapters, and maybe I'll start out and take a look. These two should be the same thing, but let me open this up. I'll pull out one of these cards. So these are small cards that should allow me to basically insert into those PCIe X4 slots, which again, I'm just doing a physical connector there. It's not, I'm of course not doing anything with PCIe as far as communication. This is my own little proprietary, but I'm just running all the different signals. So I've got 32 signals on each of these that I can run through one of these little cards. And the idea is that this card will let me then plug in my Agilent logic analyzer, which uses cables that look like this. But each of these pod cables that go to my logic analyzer, the idea is that these would connect on here and then click into there. And I should have plenty of room, so all these cables can run off to the left. And I'll have 4 of these in if I actually want to be using all 4 and capturing all those signals. But this card has the appropriate resistors and capacitors according to what Agilent is expecting on the end of these pod cables. Also, I have headers so that instead of pulling the signals from this little PCIe connector, I can just plug whatever I want into signals directly into this header. So this can be a standalone card too. I can plug these in, have my input headers, and connect up my 32 different signals, plus 2 different clock sources, or I'll just use one clock source, but plus the clock source, and take that straight from these pin headers into my Agilent. So that should be handy. Now this here, I'm guessing, will be the assembled. This is the first time I've ever tried ordering assembled cards, and at least for all the surface mounts. So yep, that's what we got there. And let's just see what these look like. And I don't know how well the camera will pick these up, but this card's a little bit different. Now I do notice, for some reason, these, I'll have to go back. I'm missing, it looks like I'm missing the copper fill. And I'm pretty sure I had copper fill on there. And I can tell because this one looks lighter, and I can see where the copper fill is not, and that would match this other green. So I'll have to see what happened there if I messed something up. I'm pretty sure I had copper fill on all of this. Hopefully these won't even get used. I had just ordered a set that were not populated in case I have issues with the ones that I ordered that were populated. But as I look at this little card, and again, I don't know how well the camera will pick this up, but I just need to add my pin headers. And other than that, they've already put on all of these tiny little resistors. So I have some 0603s for the resistors. And I can do those myself. I have a little IR oven that I can, using a stencil, which I'll talk about that in a second, quickly paste this, and it wouldn't take that much to place all of those, and then to run it through the oven and then do any cleanup after that. But I can do that with ease if I want. But saying that, I did forget to order the stencil for this. So probably the next order I have put in for something, I will add the order for the stencil for this. Or maybe I'll even modify this card in the next round and make sure I get a stencil for it. So I forgot to do that. So that means that this will take a little bit more effort to get populated without that stencil. But looking at this, it's looking pretty good. So I'll have to get it under a microscope and just see if I can validate all the right values are there. But I don't know why there would be any issues with that. So I've got 10 of those built and populated, ready to go. Obviously, I only need 4 for this, so I've got 6 spares. But that's fine. The incremental cost to add an additional 5 boards is pretty minimal. So I ordered 10 populated, 10 unpopulated. So that's what these guys are. Okay, let's set those off to the side. Something else I then did, and I'll be curious what these look like. I have some small PCBs, and what I'm looking to be able to do is see if I can make my own flavor of these cables for the Agilent. So if you've watched some of the videos on my YouTube channel, I have 2 Agilent 1680s. I have a 1680A and a 1680AD. And I picked the AD up, and it was not functional. I was able to get it up and running, and looks like everything is testing out fine so far. But it did not come with a set of pod cables for this second unit I have. The first set I have all the pod cables, so I can obviously pull the pod cables from the first unit and use those. But I thought it might be nice to see, could I make my own pod cables? There is a blog out there where someone took one of these and kind of deconstructed it. And this is not a simple cable to build. And I actually even looked into, can I get these connectors? And I think I can. But then the equipment to actually connect the ribbon to that was crazy expensive, like $5,000 just for the cable cutter. There's the way that these cables go into, at least the adapters I found, is it takes a 40-pin cable and then basically cuts every other pin shorter, and it goes in and gets basically crimped on or pressed on to the adapter. And that was just for the cable cutter. And then, of course, the actual die or the tool to compress it together probably was another $5,000. It was out of my league as far as spend or anything that made sense to try to do. So then the question is, how do I get this connector, which is not a very easy to find connector. It's not a real standard connector as far as, like a two row 2.54 pitch type of connector. It's actually a 1.27 pitch between each of the columns here, and then it's double that between the rows, so the 2.54. So then the question is, how can I get that going? I did source these connectors, which I think are close. They're not quite right, but the pitches should be right. So the 1.27 and the 2.54. And you can see maybe if I flip this over, there's actually 4 rows of pins on this. So this is a 60-pin connector. And what I'm doing here with this adapter, hopefully the idea is that that 60-pin connector goes on there like that. And I'll solder that. And then coming out of that, I break it out to a pair of 2x20, so 40-pin standard type of pin headers. And I do that breakout in a way that matches what I would see from this 60-pin to these pair of 40 pins. So a lot of it is grounding wires, so there's a lot of ground wires in there. So when I look at these 40s, basically you're going to see a bunch of them are grounds. But if I've measured this and I think this will fit, so I will solder this in. I might have to trim these pins down, the leads that go through the PCB down as far as I can get them, basically flush. Then this actually will fit in the back of the Agilent. So this will click in and fit. And then I'll have these beyond where it connects into the Agilent, and I can connect a pair of ribbon cables. So for that, I am connecting a pair of 40s, not a pair of, whatever these are. I think they, on the ribbon, don't send all the ground signals through, so they trim down the number of pins in the ribbon, and then at the other end they have another little PCB in here that splits it out. So I think there's, if I remember right, a little PCB here that goes from 60 to these pair of ribbons, and those pair of ribbons then have to get split back out into the 40s. That seemed like a lot of work. The benefit or the convenience factor is these are nice narrow ribbons for all practical purposes. But I think what I can do is take a 40 and I'll actually split the 40 down the middle, and I'll bring it together and probably just put a cable cover over it. But I'll have 2 40s then, and that will come out to 2 40s on the other end that I can then plug in, for example, to this card that will go into my board. So we'll see if all that works. This is not just standard ribbon cable. There's some other stuff in it, or the way it's built is a little bit different, but I don't know. I need to experiment there and see if I can make that work or not. But the goal would be use this little custom adapter I built, plug it into the Agilent, plug the ribbons in. Ribbons then connect to this little board. This board plugs into here like so. And maybe then see if I can get those signals working on the Agilent. So more to come on that. And I did also put in some, you might not be able to see them real well here, but I did put in some locations so that I can put a physical fastener, and I already have a plan for that I can then physically fasten this into the back of the Agilent. So if I look at these cables here, the way they work is that they're physically, there's a screw and with kind of a built-in flat washer piece that locks these in. This, of course, won't have that. But with these little adapters, I have a little physical L piece, a little copper L piece that will let me take this in and then screw it in and lock it in. So we'll see how that all plays out. But my first question and concern was this physical connection. And that looks like that's working. And that was a custom component that I put together in Easy EDA. So we'll see how that all plays out. But physically, it looks like it's good so far. Now, one thing I will note, this piece that I ordered here, this connector, is not exactly what I'm looking for here. And what's a little bit different with it is, again, I don't know if the camera is going to pick this up, but there's a little bit more plastic on the connector. And so my intention is just to trim off a tiny little piece here and here. All the pin connectors are exactly the same. It's just this connector has a little bit extra of this in the molding. So I will zip that off pretty easily. And then this should be able to plug in to the system. So we'll see. I'll make a separate video on that later and see if I have any success with that or if that is a wasted or failed attempt. 2 other things I have left here. So if I open this up, this is going to be another one of these types of cards that plugs into these debug ports. And I think moving forward, if this ends up working out on this board, this might be just my standard way of connecting debug connections basically to my different builds, whatever I'm building. I'll just put on 1, 2, 3, or 4 of these, and then use these types of standard cards to get to it. Now what this card is same in concept, but instead of going to the Agilent, which is what this is for, this is going to go to a PCB, this up here, which I'll open in a second, that then will go to my PC. So I've previously posted videos where I've kind of written this little Windows debugger type of tool, or basically it logs signals and lets me kind of see them, and that's worked really well. And the last one I did was an STM32 based. I've done a nano based. This one here is going to go to a Teensy, and maybe I can open this one then. And so when I take a look at this 4 of these basically will come together and connect to one of these. And so I can come up here and have 4 of these. Again, they'll connect like this. But I'm going to flip it over just so you can see the top side of them. But if I've got this all right, I should be able to come in here and put in these 4 connectors. I do have this lined up so that if I need to put in some physical bracing and into an ISA slot, this should fit that ISA slot basically on the chassis. I don't know if that physical, I don't know how well these are going to hold up without some physical reinforcement, but we'll see. But these will plug in. And what I've done is I've built this little card that will host a Teensy on it. And then I'll have a small ribbon cable that goes from each of these 4 to here. And so instead of the big set of cables like this, or the 40 pins that are going to go over to my Agilent, this will just take a tiny little ribbon, and it'll take one from each of these cards and bring it over into these 4 locations that will get it to my Teensy. Now what I'm doing is on these small cards, I have my basically shifters. So I can shift in, I can read a signal, I can shift it in and bring it through serial over to these adapters, these connectors here. That's all going to be 5 volt. And then here I'm going to then level that. And I kind of changed my approach in the previous debug card I had for the STM32. I had a bi-directional leveler, voltage leveler. And I wasn't liking that. It was causing some unnecessary noise, and I had to do some workarounds as far as enabling and disabling those when I wasn't using them. Otherwise, it was impacting other signals. This here, the levelers I'm going to go with, they have a direction signal. So I'm going to set them all so that's inbound only, really for what I'm doing here. But I'll bring in all of the signals in as 5 volt. They'll go through the levelers to the 3.3, and then this Teensy can work with all those 3.3 volt signals. And I don't have to worry about blowing up something on my Teensy on the I/O pins because I accidentally put a 5 volt in. So I think that is going to be handy. I've not done any work with the Teensy yet, so I'm kind of making an assumption that this is all going to be something that I can do that's workable, but we'll get in and play with it and see what I come up with here. But that's the idea. So I will have some updated videos later, and I'll start with trying to get the upper board of this working again. Back to this thing. So can I get just the basic system running like I had it before? I will probably start out with maybe trying to get one of these and the Teensy working. So that might be a video all on its own. It's just covering that part of it. Maybe I'll post a video just trying to get the core of this running again, and if I have any problems along the way. So there is a lot of room for problems because I did a lot of changes as I laid this out, and we'll see if I messed anything up too badly. If I can get this working along with this, that will be a good sign. And then the next thing I'll try to do is get these working together with my Agilent. And that'll give me now actual some hands-on with those Agilent logic analyzers, just kind of learn the software and see if I can really get some of the value out of them or what they're capable of doing. And then after that, I'll add this in and see if I can now start to get some type of device in a slot working. And I think a video card would be a really nice place to start there. After the video card, then if I make it that far, then I can move on to my IDE controller and see if I can then get that working. So lots of work to do here, and this is going to take time. So I'm in no rush to work my way through this, just kind of having fun doing this. I'm still doing some stuff over on the other side on my 286 or 386SX system, and maybe at some point I'll post some updates on that too, but maybe in the next couple weeks, I'll see if I can have an update on trying to get this up and running, at least the core of it. So I think that is it for this video. I've got my lower board, upper board, got a debug for my Agilent. I have potentially an option to go with a custom cable with this adapter. I have this adapter and this card to run to my own little debug setup. So I can either go to my logic analyzer or my little custom debug setup, which I do like. And that should be about it. If you got any questions, any thoughts on that, let me know. But I just thought I'd share. Got a fun package of stuff to play with now. And then I need to get in and see how much of it's going to work and how much of it just is not going to work because I missed something important. Thanks for watching, and more to come.